Project Hot Metal is an educational project aiming to teach engineering students how to operate a metal additive manufacturing machine. With dual platform support of PC and VR, the goal of the project is to simulate the operation of a metal AM machine and provide instructional support for engineering students. There are 3 stages of learning. The instructor will teach students in the class first, then the students will go home and review the learning material on their PC. Lastly, they will practice again in our VR linear tutorial.
We collaborate with Human-Computer Interaction Institute for the web-based PC version. We build the tutorial on CTAT, the cognitive tutor authoring tool. CTAT performs as a backend server for displaying instructions on web pages, and also serves as a tool to record student behaviors and analyze the data in the future. Hints and visual feedback will be given to help the students go through it step by step.
After students finish the PC module, they will enter our VR experience. The tablet on their left hand will provide them instructional support. The tablet can be turned on and off based on the preference of the student or the instructor. We have 2 kinds of hints available apart from the text instructions. Objects will have a yellow outline if they are to be interacted with, and their respective target locations will glow yellow. These hints can also be turned on and off depending on the student's preference. Touching different parts of the machine will also reveal floating tags if students would like to know the names of the objects.
So the instructions are designed in such a way that they first begin with simple interactions, and as the experience progresses, the complexity of interaction increases. There are 3 main interactions in our VR version: touch, grab, and move. The students use the trigger on the back of the VR controller to interact with different objects. Our delivery goal is to provide a complete, detailed linear tutorial experience. Therefore, we follow 2 development criteria. We imitate the operation part of the EOS printer as simulative and as fluent as possible, and we also build a solid framework architecture for future refinement.
In order to create a learning experience that can be transferred to operating the actual machine, we want to achieve fidelity and realism for this project. We emphasize on creating 3D model and texture that are as close to the real machine as possible. Since the manufacturer didn't disclose much information about the machine, we need to heavily rely on observation and references. We visited the lab multiple times and took a lot of reference photos, and we're not only referencing them when building the outlook of the machine, but also the mechanism of the machine.